Good morning. Welcome to another week, another Wednesday webinar, Wales Darby. Got myself, Rick Koester, Anthony Tassi over here.
Good morning, everyone.
Side. Talking today, all things SpacePak. So as you guys are coming in the room, we got a lot of people registered today, a lot of people coming in already. Just make sure audio is good. Give us a sign, little something in the chat box. Let us know you can hear.
Hello.
Also, if you don't mind, throw in where you're calling in or where you're watching from today. We'd love to see where you guys, I know we're growing. I think I've seen Hawaii. So whoever that person's with us today, say hi.
That's an early morning.
That's a real early morning.
That's like yesterday still.
So we got some good. We got some people coming through. Joseph, thank you, Vince. So we're going to talk a little bit, just have a conversation about, pretty much everything SpacePak. There's some
Florida Keys.
Florida Keys. We got a Florida Keys.
There's a lot of SpacePak down there.
Nice and warm down there. So we're going to talk about not just the high velocity side that everybody seems to know, but maybe some other things that you didn't know. So hopefully we give you some information. Again, it's going to be a conversation, so your participation would be greatly appreciated. We have some fun with these webinars. So when you guys are interacting, asking questions, giving us some information, we all learn, right? So just moving forward here, let me see if I can advance.
Don't forget your handouts, just to mention that again. There's some good information in that.
Come on, you're killing me.
I know.
All right.
So
like Anthony said, you got a little handout section in your dashboard there. You'll be able to download some of these items. I only got 3 on the screen, but you'll find 5 items in that box. We threw in our current list, we call that a trade price book, right? So that's not what you're buying it for, that's just a trade price. But that's going to cover everything SpacePak there that's current. We got our solutions or our tips and tricks. So that's another good one. A lot of what we take from our certification web classes that we do, that information is provided inside of there. We're not going to go in deep like we do a certification class. It takes a couple hours. We're going to spend, 45 minutes, an hour, hour and a half today. We'll see how the conversation goes. But you'll have a lot more information in that packet. I encourage you to reach out to your distributors if you're looking for, full-blown certification. We do them both, not just, small duct, but we also do it on the hydronic side as well. So we'll talk about that a little bit more. So definitely don't forget to download. If I get this to work, here we go. So Blake, take some notes too. There's some information you're looking for afterwards. You'll have our contact information at the end. You'll be able to reach out to us, myself, Anthony, Jim, John, Rob, any one of us in the Contractor Services Group. You'll see those 3 pages. It's really only one PDF. That's our contact sheet. So you'll find our phone numbers there, our direct contacts, as well as all the other manufacturers that we do represent. So it's taken up a lot of space now. We got to go to 3 pages now, right? So a lot of good stuff going on there. The other 2 I left in there, I believe, was a brochure, full-line brochure, as well as the pre-sale support form, and I'll talk about that in a few minutes. So like I said, when most people hear SpacePak, and if you don't mind, also throw it in the chat, have you done SpacePak before? Have you done the air side? Have you done the water side? Have you a little bit of both? Are you plumbers? We'd love to hear a little bit about you guys and what you guys are doing and who's what, love to know who our audience is. But yeah, like I said, most people, when they hear the word SpacePak, I would say they probably think of small duct high velocity. Right, that's probably the most common. Been around for a long, long, long time. Do we know the year when small duct? And you're usually the history guy when it comes to that stuff.
60s.
60s. Okay, we'll go with
Probably
that.
even earlier, but 60s. Safe to say.
So the coverage area of Wales Darby and where we are in the New York, New Jersey area, lower New York, we see, we call it the Mecca up in the Bronx up there. Mount Vernon, Westchester, all of that, even New Jersey. A lot of SpacePak high velocity for good reason. The 2-inch ducts, those small ducts you see in the top of the screen there. It should be able to, let me see, is this working today? Yeah, there you go. All right. Make sure we've got some reference there. So small duct high velocity, HV, that's traditional refrigerant and now could be, heat pump. When we talk about heat pump, and that's going to be a big conversation today, we do a lot of new stuff coming out, but we can go traditionally air conditioning only, or we can go, and that's always going to be by others there. I got a little note down there. SpacePak does not make a condenser. They make the air handler and the whole air side of the system. So it gives you guys, you can be creative, you know, you can go with your favorite condenser, whoever that may be. If you want to go heat pump, right, we have some good options there. A lot of inverter technology coming out. So definitely helping with the efficiencies. Most of these systems are compatible and matched on AHRI, which is nice. So if you guys are into rebates and stuff like that, and you're looking for AHRI numbers or whatever that may be, I forget what the number is now, but a couple hundred systems that we are matched with by others, you know, as far as the condenser to air handler matchup.
Yeah, it jumped.
I think this year alone, you know, it's hard to keep up with all these new units, but you know, there's some good matches out there. So the side that, you know, what I think we don't see, it's obviously grown in the last couple of years, is the hydronic side, and I think that's kind of forgotten a little bit, and that's why we love doing these webinars as awareness and having these conversations about best practices and all that stuff. You know, it's bringing light to this hydronic side of SpacePak. It's not just air, and we can have a combination of the two together on the same application. But the hydronic side is definitely going to be a good conversation point later on this morning. We'll cover the small duct side as we get going. But hydronics is a huge thing for us right now, a huge thing for Wales Darby in general, you know, with all the other manufacturers we rep as far as putting a system together. So we can definitely help there. So regardless, whether it's small duct high velocity or it's the hydronic side we're talking about, it all starts with a design, right? It's always, you know, whether you're talking about a boiler, doesn't really matter what we're talking about, any application, you know, there has to be a design side. And that's one of the big things with SpacePak. You know, we have something called pre-sale support, and you know, working with, and Anthony, I'm sure you would agree, you know, with all these manufacturers that we work with, and seeing, you know, even some others out there that have some kind of support and design assistance. You know, I've never seen anything like what SpacePak offers. You know, there's no cost, right? They don't charge you for the design, but they have this pre-sale support team up at Mestech up in Massachusetts, not too far from here. But they're a bunch of talented application engineers. And when I say a bunch, we're probably talking maybe three, right? They're probably pretty small, 2 or 3 guys. When we say here, provide optimal turnaround, I mean, the numbers that they turn out are pretty impressive. You know, you submit a design layout using that form that's in your handout section there. And these guys will turn around a design usually in 48 to 72 hours, somewhere around there. I mean, it's pretty damn quick. But as far as anything regarding your system design, layout, questions about selection of equipment, they're going to provide all of that to you. This is one of those, you know, the more information you put in, the more info you're going to get out of it. So we just got to be, you know, if it's your first time putting something in, definitely reach out to myself or Anthony or Jim, John, or Rob on the New Jersey side here. You know, we can help you fill this form out, make sure you got the right information, make sure some of those questions are being answered, and we submit that. There is an email right there, pre-sale support at SpacePak. You submit that form to them, and you're going to get something that looks like this. This is a good example of it. This is one I did a while back with another contractor, but you're going to get nothing special, nothing you couldn't do on your own. They're just doing it for you. Is this manual J? You can see the right soft logo down here in the corner. You know, so this is the manual J they're doing for you. And based on the room outlets, this is a high velocity system. Based on the room outlets and some rules that we do follow, they can come up with how many outlets per room. So that's going to get us a good starting point. You're also going to get this right sheet here. This is going to be a material list. So you're going to get a basic breakdown of all the parts and pieces you need. From here, I would say, you know, when this comes back, typically we like to, if it's your first job or first couple jobs, we'd like to go walk this job with you. You know, go see what's there, and is it feasible to make sure all our ductwork's going to line up so we can stick with those outlets for room numbers. You know, there's some, I know Anthony, you were just dealing with a project that was, you know, maybe 30, 40, 50-foot runs, you know, as far as the 2-inch ductwork goes. You know, we might not be able to do, we might have to add additional outlets, and we'll talk about that in a few minutes. But, you know, this list is not the end all. We want to see that project, make sure everything's going to lay out the way we want it. This is just a copy of that design form, right? So again, don't forget to download that, take that with you today. If you have a project, even if it's something, you know, you're thinking about SpacePak at the end of this, you know, put something together and give us a shout, see us on it, and we'd love to talk about that.
Yeah, liability is real when it comes to if you're doing a design, if you're laying out your ductwork, you better understand how to control airflow. And SpacePak, the engineering behind high velocity,
Yeah.
it's simplified. And if you play within the parameters, you'll have less headaches. And sometimes you can go longer, but
Absolutely.
you got to know to make up the BTU delivery.
Right. We're just gonna, talking this morning just on basic, design or layout of a high velocity system. As you can see on the screen, that's a blow up of all our system components. And what's really nice, the breakdown. If you're doing a 2.5 ton system or 2 ton system, we can give you a pretty good layout without even seeing anything, until we know how many outlets and everything there, how much duct work we could run. But when we talk about skilled labor and finding people today to do these installations, it's not getting better. We're losing guys. We don't have new guys coming in. So obviously when you're laying out, if this was a traditional system, there's a lot of hands involved, between doing the load calculation, right, then doing the duct layout, right, picking all your parts and pieces, quoting the job. This could be a lot of hands. And I think some of the guys, and looking at the list of people that were registered today, I know a lot of these guys that are here today, maybe you're doing this by themselves, so it is time consuming to set
Time
up
and
or
talent.
design, right. And now, SpacePak kind of takes a little of that away, and what I mean by that is our duct size is 2 inch and 9 inch, right? It's not much more than that. It's a fully engineered system is really the best way to put it. You're not going out with a ductulator and trying to calculate, your runs and all of that. 2 and 9. We got 2 inch outlets, 9 inch plenum. Can we go beyond a 9 inch and be creative? Absolutely.
Right.
The magic behind a 9 inch is really the 64 square inches. And if we play with that
Sealed. It's got to be pressure tested.
Yeah, right. We've got to hold all that static in there. High velocity not being traditional, right? We don't accept air leakage, right? We don't want air leakage. We deflate the balloon. We're not going to get the delivery of those BTUs to the space, but our 9 inch is, there's a premium to it for good reason. And I got a couple images of examples of that duct, but that 9 inch alone, we can run that out possibly 250 feet away, equivalent length. So that's total equivalent. We get some elbows in there like this example and a T right off the bat. We're 45 feet, 15 feet for elbows, 30 feet for T's, right? We take that into consideration. Now we're 205 feet, right? A straight run we can possibly run. It's still a ton of duct work, that we can get up in an attic. We always want to see more plenum and less than a 2 inch because that's what's going to balance the system. So we do have different configurations. We talk about different methods of running that trunk work and branch systems and all of that, which we get more in depth with our certification classes. But if you can remember 2 and 9, I mean, you're pretty much your design, your duct design is done. It's more distance. How far do we have to go with this? How many outlets per ton are we putting in, or how many outlets for this job? So there's some creative ways there that we can, put a system together.
I was going to say, when the light bulb goes off and you get this as the part of the SpacePak, man, it just makes everything click. And if you're a small crew, small independent, you don't need to have a big staff to start doing a lot of this stuff.
Right.
The clientele is a different kind of breed, believe it or not. They're really looking at the aesthetics of the outlets, and there's money to be made. And man, if you simplify it, you can run the machine pretty quickly and start covering a lot of ground.
Absolutely. Absolutely.
It's neat stuff.
So that's our plenum pretty much. And then when we talk about those outlets, and again, I have 7 outlets per ton up there. We have some, might see some slides at 6 outlets per ton. I always like to make sure we're covering our butts here, but 7 outlets per ton, we just remember that, it's pretty easy to at least get a general idea on how the system's going to go together, right? More 9 inch plenum as far as we can run that. And if we can keep all those outlets per ton, right? If we can keep all those 2 inch lines, let's call them 50. I know Anthony, you like 13 feet, right? So 13 to 15 feet. That system's well balanced. There's nothing to worry there. As long as we keep the air in that duct, that 9 inch, and we're not leaking it all out, your delivery is going to be pretty even throughout the entire system, which is really, really nice. So
it's the repeatable side. Exactly. So why 15, 13, splitting hairs here? The 2 inch comes in the master box of 100 foot,
right.
R6. R8, if you need by code, it comes in 75 foot. So every last 3 feet is a sound attenuator. So that's why I say 100 foot box, cut into 10 foot sections, 13 feet. You're good to go.
Yeah, save material. So
right. No waste.
Yep, no waste whatsoever. So like Anthony said, you can kind of see them here. They're kind of turned a little bit, but there's your 2-inch duct that we were talking about. And then here's our sound attenuator before we end up with our termination, our little round disc, right? So, pretty simple to put together, quick connects, which are real nice. But if I can go in, I know I'm doing it's a 3-ton system, yeah, we can do some simple math and say it's going to be 21 outlets per ton. That might be a good way to budget a system, but we need to do a design. You need to know how many BTUs, unlike traditional where we're trying to figure out CFMs and all this air delivery. That's one portion you can kind of save some time with, as far as a design, is understanding how we size our rooms based on BTUs, how much air do we have to deliver.
The other thing, if I may add, is once you kind of get the light bulb moment, obviously you have your cost per outlet, what it takes for 10 feet and the cost of the kits and all, you can almost do a pre-build. You can bring these things pre-build to the job site after the plan has been laid out. So there's some rhythm to it where all of a sudden you have speed. Small crews get it done quicker.
Right.
It's nice.
Talking labor, right? Not being able to get guys. I mean, this is very easy because they don't have to, there's no thinking. 9-inch is 9-inch all the way around.
Yeah.
Now, I think where we talk and we hear, and I know you brought it up before we got started this morning, when you start it from scratch, everything's pretty easy. You put in a system together, we design it properly, everything's great. But for the most part, what we're seeing out there today is we're seeing a lot of retrofits at this point.
All the systems being replaced.
Yeah, old air handlers finally taking it, 22, systems that are still out there, right? They're being decommissioned, and now, we got, equipment replacement, but there's a little bit more than that. It's not just equipment replacement, and this is where guys get into trouble. We're seeing that a lot, and it doesn't matter what region you're in, everybody's doing it. We do have something, I know we hate to read, right? But the installation manual comes with the equipment. We specifically cover something called retrofits. Reason we do that is, older times, older equipment, we were talking PSC motors, single speed at best, and, there wasn't much rule. I guess there wasn't much forgiveness is what I'm looking for with that system. It was low airflow, it wasn't as high as what we have today. Now we go with the newer equipment and we're talking 30% more airflow. So now we go and do an equipment swap, and we still had maybe some old 7-inch duct, that the way it used to be. And now we're putting this new machine on, we're on smaller ducts with higher airflow. You should, kind of get where I'm going with this. You're going to have some noises, you're going to have some unhappy customers. And that's where, unfortunately, we end up having to step in sometimes. The manufacturer reaches out to us, SpacePak calls us directly with these problem jobs. Homeowners are ready to rip stuff out. I got 2 I have to go take a look at, and I can almost guarantee you what the problem was. And, you can't blame the system. I hate hearing that was pre-existing. If it was there, it's something we should have looked at, right? And some of it, unfortunately. Yep.
Can you click the slide? I think you have a picture of the elbow. Don't you have some fittings next?
Yeah.
There you go. Someone's asking about the duct work.
Okay.
It's made out of metal, insulation.
Good timing.
Yeah,
Good
perfect.
timing. So yeah, that is our duct work there. But when you look at some of the 7-inch that might be on a job, if you are doing a retrofit, it could be duct board or fiberboard. There were those old systems out there that were square duct. So if we are starting to retrofit, or you are walking upon jobs where they have a SpacePak system and they're looking for just the coil is leaking, it's old, it's rotted, whatever the case is, and we're changing, upgrading everything now. It's something we got to look at more is the air side. We want to know how many outlets are in there. What do they currently have? Because what they currently have might not be enough. They might have to add, and that's part of the install manual, and so we have, right? It says may or may not have to add more outlets or increase duct size, right? So sometimes looking at that, I know some of the applications you've been on and some of the ones I've been on, we've been able to keep a majority of the 7-inch, maybe run some new 9-inch as far as we could see, and then transition into that 7 and maybe add 2 or 3 outlets here. But for the most part, it's not a just swap it out and we're all good, because I can guarantee if you do, there's going to be a callback and you're going to be getting complaints of this thing's rumbling and making some noises. What's really nice about some of the newer equipment, it's new, and I think you just mentioned it was ECM. We went to ECM blowers. We actually have a really nice motor in this thing, a blower. you don't see in many applications or many manufacturers, but it's a newer, what do you call it, Deck Star, I believe is the motor, but it's, that's where we get out 30% more airflow, right? There's no blockage, there's no big motor in the squirrel cage there. So if you haven't seen, definitely jump into one of our classes. I know we have an air handler we bring into our classes that we can show that thing off. But the point being is that thing is variable. It does, it's constant torque, you can say, so or constant static. So that thing's going to ramp up. We can, without new boards, basically pick a static pressure we want to be at, So we have some flexibility there based on, how many outlets are in the space. Can we drop the airflow down a little bit more lenient when we talk about the water side? We start getting into refrigerant, we don't want to freeze coils and stuff like that. So we need that proper airflow.
It's still the basis of refrigeration, need airflow,
Absolutely.
clean coils.
And I think that's where we kind of see some guys get in trouble is they try to compensate, maybe the airflow side, for a noise issue, and now we got frozen coils going on, and this thing's going on and off all day. So, these are the things we just got to pay attention to. If it is a retrofit, don't just take a model number and get some new equipment. Look at the whole system. If you're unsure, give us a call. We'll come take a look with you.
Make an emphasis, if you look at any of the model numbers of our air handlers, there's a letter representing the series. So from F, G, J's now, J pluses. So you can see there's been a generational technology advanced. So that's the new ECMs and the J's.
Right.
So anything older than that, if you're replacing it, you're best to understand how many outlets per ton. And like Rick is saying, just don't go after the air handler side.
Yeah.
All right.
Yeah, might have to add quite a few outlets.
That's
so
correct.
Just got to make
That's more times than not what we've seen inherently is that noisy system, and it's pretty quickly to figure out. Not even talking about lengths of the 2-inch yet, just how many outlets, and why are you 8 short for this air handler size?
Right. The conversation's easy to have in the beginning when we're walking a job and looking at replacing it, and we give the homeowner some, possibilities. This might, this may, the worst conversation is after the fact, and that's usually when we land on it, is you've already been paid, but now there's a complaint. And now you got to go spend another $1,000 to go add a couple of outlets, it's not a good conversation.
Right, who's paying for that?
Right, so.
You
Want you guys to protect yourself. So yeah, so those the pictures of the duct there. So I'm glad. Who was that asked?
That was Mr. Edward.
Edward, thank you. Good time. So that material. So we had a question about the duct and what is it made out of. So it's it's a steel pipe. Yeah, 26 gauge steel pipe. It's what's unique about it is it's gasketed.
No flexible elbows.
Correct.
If you're going to do some flexible, you got to understand, we need to keep the static and the pressures in that plenum, right? And if you have something that's going to blow up, flexible tubing, I've seen some really funky installs, but you got to understand the quality that we're offering as a system. It's just taking all your liability away.
Right. What's nice about it too, sealed wise, up to 10 inches of static. It's
you don't need that.
Yeah. Yeah.
That's what it's proven to. And that's pretty solid.
Proven. We're running at 1.3 in most cases, right? 1.2, 1.3, but we can, the duct is 100% sealed.
And those are long radius elbows.
Right.
Again.
Right. So
short,
tight together and
increases.
Putting a screw in, and that's pretty much it. Hanging them. Now, what's nice about the lengths is they do come in 6 foot.
6 foot.
6 foot lengths.
Someone was asking about that as well.
Perfect. So 6 foot lengths. They do come pre-insulated. You get about 10 feet of insulation on there on a 6-inch length. Reason being, so we can cover those elbows, T's, and whatever other fittings we may have in the system. So very easy. Yeah, there is a cost to it, but it's pre-insulated. It's gasketed. No loss. You're not sealing ducts afterwards. So there's a trade-off there.
Can you talk about zoning if you want to touch on that?
Yeah, we can touch on that. We got the little T up there, so absolutely.
Right, exactly, before you turn.
Yeah.
Excellent.
So going through, just continuing with the duct work, zoning we definitely talk about it.
Just quickly, what we can do, I guess it's possible.
Zoning is definitely possible. It's actually exciting with high velocity with some of the systems that we do have. What was it? Not that you can't use other 9-inch round or by others, that's definitely there. It's just a matter of keeping the air, keeping that balloon inflated. You want to use materials like Anthony said, no flexible elbows that are going to blow apart under 1.3 inches of static. But, square duct, we got to go rectangle? Yeah, we could do that. I got a project now, down in Chelsea in Manhattan, that's a little funky. I don't think we have any round duct, on the whole system. It's all going to be kind of custom duct work, but they follow the rules. It's 64 square inches is that magic number. You don't want to go too far over that. We don't want to oversize it, but 64 square inches is going to be that sweet spot. Can we go rectangle? 64 would be 8 by 8 square, but maybe I can go 3 by whatever that comes out to. I don't know. I'm not doing math. It's too early in the morning. But
22.
Just throwing, let's call it a 3 by 22. I don't think it's that big, but it's close. It's the more rectangle you get, is the more problems you're going to have with ballooning that ductwork and now having to support it. So it's a lot more labor to go back. And I mean, if you have to do it, and that's kind of the project I've been, watching over a little bit. They have a lot of this, and there's going to have to be an understanding of bracing ducts. And when this thing turns on and turns off, we don't want to hear that in a home. So
That's right.
it's just more of an education at that point. So can we do it? Absolutely. It's just a matter of doing it correctly.
And just to throw it out there, we say 9, that's the pipe, and then we have the insulation, so call it 12,
Actual
without
pipe.
compromising the R value.
Same thing with the 2. The 2 is really
Right.
4, somewhere around there, without crushing it. So yeah, talking about zoning, I mean, you see a little T up here, right? So we could possibly, zone this system, and there's a couple different ways. We can either zone by, an actual branch, right? So we would have a damper system in there. SpacePak does have a partnership with Arzel. So we do have our own zoning kits that you can purchase. We'd say 2 to 3 zones, the max. Once we start getting into the zones, though, we got to look at those outlets per ton. They start to bump up a little bit. We got to have a minimum. If you are utilizing maybe some of the inverter technology today with heat pumps, some of the guys that are out there today, condenser-wise, that definitely makes it interesting, because, where traditionally if we have a AC-only system, we really can't change the capacity coming out of that condenser. So we always got to have the proper airflow. There are no bypasses like a traditional system, but we do have to have a minimum amount of airflow. So we got to get a little, pay special attention to how many outlets per ton we have there. We could also zone by an individual 2-inch outlet, right? So we can put a bunch of them in, again, quick connects. That's a pressure tube, type of system, a little air pump there that's going to fill up a little bag and shut off air to that system or to that room or outlet. So pneumatic, thank you. That's a good way to put it. So yes, we do have some systems like that, and square end and round duct as far as the dampers go, as if you would do in a branch. So if that is an opportunity for you, and who was asking that? Who we got? Is it Stephen? Who was asking about the zoning? Was it Stephen? No, I don't see.
Stephen,
good question. But yeah, we see zoning a lot. Actually that same project, I mean, I think every system we have there has at least 2 zones or 3 zones. So just adding more to the job. I like keeping things simple. If you don't have to zone, one of the things, I didn't even mention it, when we talk about why high velocity, when you talk about the comfort that comes out of high velocity and dehumidification, right? 30% more, it's amazing. For 30% more humidity removal in the space. So when you think about temperatures and where we leave our thermostats and stuff like that, we can raise those temperatures now because we're controlling the humidity so much better with this system. I remember one of the first jobs I was on with a SpacePak unit on a startup, within less than 5 minutes, let's call it 10 minutes, 5 to 10, I'll be nice. It was probably less than that, but you look at the drain coming down from the condensate up in the attic, and I mean, this thing, it was like somebody turned on a garden hose. The amount of air, the amount of water coming out of the air.
brand new coil, clean.
Brand new coil, yeah. It's just amazing how much. So that's really the main benefit of small duct high velocity is the comfort, energy savings. That's what we always talk about with SpacePak is energy savings. High efficiency, there's a cost to high efficiency. You're going to be more comfortable at a higher set point. So if you've ever been around a high velocity system that's working properly, I mean, you don't hear it, it's almost silent, and just a lot better comfort in my eyes. So less than 2-degree temperature differential across the space, with high velocity.
I just want to mention that the picture is showing you a horizontal air handler. We do offer a vertical as well.
Yeah.
And that's the DX R410A. So.
You got it? I think I got that.
Oh, there you go.
There's
Good
your little
picture.
vertical air handler right there.
And there's the buy others I was thinking you had to show. So.
Yeah, we're not swapping coils. They are two different part numbers as far as the air handlers go, vertical and horizontal. So
And that the outlet there, just next to high velocity, that's what a lot of people pay for, that
Yeah,
look. the
that little
aesthetics.
guy right there. That's what sells the system. Nobody knows what the rest of it looks like. As
And
far
just
as
another
architect.
tidbit, if you go around, you have a noisy system, take a flashlight, shine it up in that outlet, you want to see like a white gauzy material. This is where you know sound attenuators were installed. If you see the shiny metal, either the sound attenuator is on the wrong side off the plenum, or it's not installed at all,
Yeah.
because there's a cost to that. And that's sometimes what people do. They take out the material, designed and engineered, quiet systems, and that's the downfall. Everyone says that noisy system on high
Oh,
velocity.
yeah. Love hearing that.
Yeah, me too.
So, not much going on the return side that we got to get too worried about. We do have some rules, and again, we can talk about that more in our certification class, but everything is engineered already, like I said from the get-go. So depending on the air handler you get, you're going to pick a return kit, which is going to have the flex that's made for that air handler. You'll get the return box. There's a whole bunch of parts and pieces there, but everything is matched to the system, which is really nice.
Odds and twos.
That's it. So, that's pretty much it on the SpacePak side, high velocity side at least. If you're running into, retrofits, or you find some applications, maybe, just hearing what you heard in the last couple minutes, open your eyes, or maybe you're thinking about some applications, get us involved, any one of the five of us.
Two more things, if I may.
Yeah.
With DX, we are heat pump ready. If you run short on refrigerant performances, we can do a backup hydrocoil, or we can do electric heaters as well. So there's a lot of things that we can add to and play nice with others.
Yep, a lot of additional bolt-ons.
Yes, neat stuff.
We like supplemental heat or redundancy in any case. So yeah, that was our small.
Correct me if I'm wrong, you put in the price book?
Yes, I
Okay.
did. Yep.
Great resource.
And a brochure, so you're gonna have everything in there.
Back 2 pages give you a typical materials list based off of tonnage.
Yep.
The biggest variable is your plenum. You better understand how much of what you need.
Yeah, if you're an airside guy and that's all you're doing, you're not so much on the hydronic side, we can do separate certification classes. We do all day classes. So reach out to your distributor. Got some good ones out there that can help you.
We can go to Maui too.
Yeah, I'd like
why
to go
not?
to Maui. Is he here? Did he pop his
I
head up?
didn't see Maui. No,
If you're from Hawaii, say hi. Love to see it.
Guy in Key West is really from Jersey. He's a snowbird this year.
Oh, there you go. Yeah, we've been looking at the list, man. We got some good people coming on.
Yeah.
Some people we're just learning about. So good relationships. So good. Any questions? Anything else you want to touch on? Anything else that came in? I saw Stephen asked about mastic. Do we have to?
Yeah.
Listen, it's not, we always talk best practices, right? It's not holding, that is sealed tight to 10 inches. Do we need a mastic? No, we don't.
More is better, but it's not needed.
Exactly.
Screws, even if you use the gasketed stuff by code, you're going to need 1 or 2. With ours, typically, man, it's going to rock solid, stay tight.
Yeah, once you push everything together.
Yeah.
You can see that's a coupling there too. I didn't mention,
Right.
but
Mentioned
that's a
about the
coupling
pipe.
between the lengths and all of that stuff. We got
Pipe
the
can be
teeth.
cut,
Exactly.
but it needs to have the connection between pipe to pipe.
The gaskets. Yeah.
The fittings, meaning the T's, 45s, and elbows, or even the caps, they're all gasketed. They go into the pipe.
Right.
The pipe is needed to join together, so a coupling is needed. The return, like Rick mentioned, it's kind of fixed to make sure we have enough CFM to get back to that coil, so we don't starve it and ice it up.
Exactly.
You can make your own. You can be creative. You can make more than one if you choose to. But really, in our world, because we pressurize and throw the air,
Yeah.
one return is more than enough if it's sized properly.
Yeah, it really comes down to, I think when I see the split returns, it's because we don't have the space.
That's
But,
right.
when you look at that air box, it says air cleaner there, and we have some nice ones there, some good features, with the air cleaner built into it. But, we have a regular filter box and then some other additional stuff we can get on there. It fits in a 16-inch joystick, and that's the way that air handler was built. It doesn't matter what size air handler you go with, it's a 16-inch, it's a 14.5-inch cabinet, I want to say height-wise, so it's going to get through a 16-inch joystick. So if we utilize that one bay for our return, it's going to get your equipment up in the attic. and you go from there. So
Kevin's asking about 2-zone. Can we run more than one return? The answer is absolutely.
yeah, absolutely. We can
Sure
do
you
2
can.
or 3 returns. You actually look at the solutions download in your handouts, right? They have some good information there on, what size based on your tonnage and everything else, and how many returns we want to do and what size. You might take, a single 19-inch return, let's call it, and be able to drop that down to 2 12s, or something like that. So take a look at that. Again, we talk about that more in our certification class. Not going to get too deep this morning.
Right.
Just more of an overview and conversation, but yeah, great question. Multiple returns doesn't hurt, but when you see the system actually operate, it's pretty wild. You can put a return anywhere in the home. That air always makes its way back there. With that aspiration and injecting that air into the space. So
Just a couple questions here about
Yep.
all things currently with SpacePak labeling is R410A. What the future brings, they will cross that when it's there.
yes,
So are they
question.
testing for some things going forward?
Yep.
I can just say R410A is the horse the ride right now.
Yeah, so that's a good point, and just a little tip, with the outdoor unit when we're setting them up, right? We always set up the system on the refrigerant side, right, based off of the outdoor unit. So we do have where is that manufacturer want their system to be optimally. I can't even say that word right now, but that's okay. So regardless of 410A, if they're using something else, yeah, there will be some changes in TXVs and stuff like that come down the road. Right now, it's all, like Anthony said, 410A. If it's a refrigerant side, that is a bi-flow TXV, so it is heat pump ready. Yeah, that's a good question. I figured we'd get a bunch of those with the refrigerant side, but you're setting them up based on the outdoor manufacturer, so we got to play nice with both sides.
Just to say, I know we want to move forward, but
There's some
DX
good questions coming in.
and heating, we have limitations. North, south, wherever you stand in our country, right?
BTUs, right?
Yeah, BTUs are BTUs. So you need to look into your heat pump of choice and what they perform under design day conditions. X amount of BTUs, they dwindle down, they're not going to carry the load. Now what do you need to make up? And that's when you choose hydronics, electric, who else? You can do by others, or you can add on to ours, and you can handshake maybe to another source. So it's the way of the world. We're going to have redundancies, we're going to have backup,
Absolutely.
and we're going to have more than one source perhaps.
Right.
So
And it's nice too. We don't have to stay refrigerant. We can go water. You want to do a hydro zone, off a boiler. We don't have to talk refrigerant, right? We can do it heating only. We can do whatever you want, and then now we get into what we got on the screen now, right? Is air to water, the hydronic side of SpacePak. That over the last couple of years, I mean, this line has been, for us, has definitely grown a lot. Just the conversations. I saw somebody put in the chat before, the heat pump conversation is crazy right now. And, you think about what's going on right now, New York City, wherever you're from, there's some kind of electrification plan, or as Anthony likes to say, decarbonization, whichever way you look at it, everybody's talking about this stuff. We have some local laws in the city, all kinds of things there where, being penalized because not having an efficient building, whatever you have going on in it, they're going to test it. And if it's not up to speed with, like buildings around the area, then you're going to get fined, So, we talk heat pumps, and I think when electrification first started, everybody was, heat pumps. But there's that generalization, that a heat pump, maybe just refrigerant, you think about your ductless systems, your mini splits, VRF, whatever you want to call it. That's the go-to for everybody. And there's some positives there, and there's some great applications for, mini splits and VRF products and, any type of ductless system. And we represent a major player in that. And, we see it and we utilize it where needed. But when we talk heat pumps in the SpacePak world, and this has been the exciting part for me, Anthony, you've had a lot of focus since I got here, 6 years ago on this.
a little longer, but yeah.
Yeah.
Well, they introduced this, what?
Well, say for me to come here 6 years ago.
Oh, absolutely.
My focus, and you bringing me on board.
One of the first things I said is, I just need you to have eyes at this.
Yeah. Right. I'm fortunate enough, I was able to install a couple of these systems in my prior life, so having a familiarity with this system. But air to water is a whole nother animal, and we're always talking skill and stuff like that. But This is an air-to-water heat pump, instead of an air-to-air heat pump, right? So, again, there's some struggles there, even with our utilities and some of our rebate, all these rebates that are popping up, and the energy companies that are playing a part of it. They kind of forgotten about this air-to-water side. They talk about ground source heat pumps, geothermal. They talk about air source heat pumps. Right? This is an air source. It's just a different media on the other side. Instead of air to air, it's an air to water product. And I know I've heard of some homeowners kind of fighting the utilities, because it is an air source heat pump, so and that's what the program says. So they want their money. But the good news is we got some new stuff coming down the line, making awareness, at the utility level and the rebate level. So we will start to see some of that come into our region, which will be nice. And it's already taken place. I saw a bunch of you guys out here from Massachusetts, Vermont, maybe. You guys are already taking, what do you call it? Yeah, taking a lead with that. You have been for years. So hopefully we see that down in our territory here. But the truth be told, we talk about boilers. We did electric last week, right? 2 weeks ago, I believe it was. We
That was a good one.
That was another air to water heat pump with some electric boiler. We like redundancy. So anytime we can match it up and utilizing the SpacePak air to water unit, with one of our NTI boilers or our electro boilers or something like that, we don't have to necessarily, take out all the fossil fuel. We work very well, hand in hand with those other hydronic systems. So for me, this was a no-brainer. And when I started approaching some of my plumbers and the contractors that I deal with, most of you guys, a lot of you guys that may be even on here today, I had a conversation. I don't know if he's on here today. I'm looking at your list real quick. I don't see him, but had Marvin. I don't see him. So Marvin was a contractor I was dealing with yesterday, and we've had some conversations over the last, let's call it year or two. Once these local laws, his business is mainly in the city area, and he came to me after a mini split, webinar. I want to change my business to heat pumps, and you think about that competitive nature of New York City, number one, just trying to compete with the amount of guys doing, heat pumps right now. As a brand new contractor, I can't see being profitable at that point. But, what I introduced him to was this type of heat pump. He's a plumber. He's got guys that know pumping and piping, right? And if you understand pumping and piping, and even if you don't, we can teach you, but it's very, very easy compared to refrigerant, and that's where when I look at a VRF system and I look at these major buildings, and if you had a refrigerant leak, I see how we handle maybe some of the residential homes, 3 or 4 indoor units, and we have refrigerant leaks. We can't find them. It could be a pain in the neck. Where water, I think somebody just mentioned, right? Was that Stephen that was mentioning the 410A, right? And refrigerant changes and stuff like that, right?
Well, he's also saying electric boiler sounds interesting.
It does.
It's very cool.
It definitely does. But when you talk about the refrigerant changes, how many refrigerant changes? I know I've been through, I think, 4 since I started in the business, 3 or 4, right? Water has never changed, right? We talk the air to water side, water has never changed. The refrigerant side on the monoblock, like you see here on the screen, this guy, that's all self-contained. Technically by code, you don't even need a refrigerant license, a 608 to handle that piece of equipment. It's already, from the factory done. You don't touch the refrigerant side. All we're touching is pumping and piping. Right? So
sizing and selection.
Talking about skilled labor again, just like the small duct high velocity. We need guys. We don't have a lot of people to do this, but if we can train, and I hate using the term cookie cut, but if you understand the basic components and how to put a system together, and we'll look at that in a second. I think that's my next slide there. But before I get off of this, you can be creative here. I think you have a lot more, on your plate, on what you can do compared to a refrigerant system. But either way, we'll look at that a little bit more as we talk about it. But this is a basic system, right? So we talk about air to water, and we can have this conversation. This is a lengthy conversation. I mean, that could be the whole thing with one slide, this whole training. But this is your basic setup, and we'll keep it really simple. I like simple things. You got an outdoor unit, right? This is a 2-part system. You got your outdoor section, right? So the red piping, the red light layout there, that's your outdoor piping. So that goes from your, what we call our battery or our buffer tank, thermal storage. We go from that to our outdoor unit, and all that outdoor unit cares about is keeping that tank at a certain temperature, whether it be chilled water or warm water, 120-degree water, right? That's our sweet spot.
120?
Yeah, 120.
Scary me now.
Yeah, low temp.
All
Right.
right, look out. Can't
So
do that.
utilizing this again, fossil fuels. This is where if you're not comfortable with low temp, maybe you do pair this with a boiler until you're comfortable and understanding of how well this thing is going to heat. But you got your outdoor section. When I talk about these outdoor units, I think one of the things and comparisons, I've had these conversations the last couple of weeks with a couple contractors on the east end of Long Island. We see a lot of geothermal, and I ask, man, the cost difference between the geothermal, drilling the wells, and some of you guys on there probably know better than I do, the cost there. But that's a huge expense, drilling, and is it vertical? Is it, horizontal? Is it like a little pipe farm out there? Whatever it is, there's a cost, and then I say, well, why not put this? And then the pushback I get is, well, they don't want to see any equipment, they don't want to see the machine out there. Well, that's where we can be creative, and you're only limited at this point to your ability to size a pump, to a pipe. Really, that's all it is. I could put this thing 100 feet away, maybe in a remote area of the property, run some Upador EcoFlex underground pipe, right? Run that into the utility room or wherever my system's going to be, and now they don't see the outdoor unit. So we can be creative with that. Actually showed up pretty good on this.
Oh,
So we're not limited to having our condensers up against the home, where they're going to see 2 or 3 of these maybe outside. We can pipe these, and I know our great Jim Bashford of SpacePak, he's had some applications where 100 feet, if not more, away from the home, and they just ran the pipes in. So if we can size a pump, which is something we do pretty well here at Wales Darby, we can help you out there. But that's your outdoor side, right? So that's your heat pump side, or your chiller, whatever you want to call it. Same machine, chiller in Florida, heat pump in New York. It's really your main purpose is what we would call it. And then we got our system side, right? Going to our terminal units. So again, that's what we already know. This might already be in the room, in the home existing. I have it matched up here to a water coil, right? Our air handler here, high velocity, but it doesn't necessarily have to be, to that point, right? We can have pre-existing stuff in the home, and if we do the design, right, we work with pre-sale support, we do a load calculation, we understand how many BTUs are needed for that space, then we're okay. Because that's really what it comes down to. I know, Anthony, you were just joking, water temp, low temp, 120 degrees, right? That scares a lot of people.
Oh,
When we talk about, what we have here, I mean, this is pretty basic. We're talking 120 degrees, maybe 44-degree chilled water going up for air conditioning, right? Some cool stuff there. So here's one of my favorite slides. I know you like this one, yeah. So this is these are just some applications based off of water temp, right? We can see from the bottom, from the bottom all the way up to, pretty much this guy here, ceiling heat. Those are all radiant type applications. Maybe the underfloor or tube and plate, or what we call our quick track, joist track. Thank you. Open on.
sorry, it was tight. I'm working over here.
Corrected myself. So moving our joist track and all of that, and running these aluminum plates, maybe that, sometimes we need some higher temps there above 120, might put us out there, but we got to look at the application of BTUs. But for the most part, we're going to hit most of those radiant applications. Snow melt is definitely a big player. I just saw a nice thing on Instagram. I didn't plug that. That was on the first slide. My fault. But saw some applications on a net zero home, with radiant, doing SpacePak Air to water units, doing some snow melt as well on another project, So we do fit in with that one nice there. Panel rads for sure, SpacePak air handlers, absolutely. And then you kind of get up into those higher temp, traditional, they call them, right? Traditional applications of cast iron radiators, or traditional thin tube baseboard, right? So maybe we can't get into those areas, but maybe we can. Yeah, we can talk about that in a second. We have some products out there too. These are
Back
nice.
up 1 second.
Yeah.
I apologize.
Sorry,
Good question.
interrupt me.
What type of condenser is going to the buffer tank?
That's a great question.
That is a great question. If you didn't see what the visual was, that is the chiller. That's the air to water. You call it condenser. We call it chiller or heat
Yep.
pump.
It depends on the stage, right? So that's
changing what we're doing here.
Yeah, your mono block, right? This outdoor unit we're talking about right here. So it's a good question. Glad you brought it up. Being a mono block, really, I mean, it is the condenser and the evaporator in one. You know, it's a full package system. You know, as far as coils go, there's a refrigerant to water, braze plate heat exchanger, or a tube and shell. I forget what they go into now. I want to say it was tube and shell in the older units.
Yes.
But there is a heat exchanger in there to transfer that energy. And we do have one, and I think I got a picture of that coming up, of a split system. I might have had it in the past. I just think it was back in the early beginning slides. I'm not going to go all the way back, but we have what we call a split system as well, which has the outdoor condenser, as you would say. And then we run refrigerant lines into the home to a box that looks like a wall-mounted boiler, and that's going to be your refrigerant to water heat exchanger in there. So now we are running refrigerant into the space. We don't need the benefit of that system. That's our SIS compared to the SIM that you see on the screen. Piping is the same. Everything you're looking from the outdoor unit or basically the piping side of it is all going to be the same. You're just not going to have any water on the outdoors. Regardless, we still got to have some sort of glycol, right? Some kind of protection in there so we don't freeze, right? Somebody asked about glycol?
Yep.
So yeah, glycol is always a conversation in the conversation. So it just depends on your application and how much we have to put in there. Might not necessarily need the full 30% glycol, you know, especially with the SIS system. The SIS, we need just enough where we're not going to freeze that water that's in the heat exchanger itself. So with that, we'd like to say 10%, maybe even less, depending on the region you're at. We're talking New York, New Jersey today, but you know, that's something we have to take into account. And when we do design these systems, look at the manuals, and we have all the multipliers for our, you know, we have some things to be worried about, right? We're not worried about, but just to be aware of. Capacity drops, pressure drops, right? So sizing pumps and understanding how many BTUs we're going to put into space. We got to take that into consideration anytime we talk about glycol, right? So that could be a
Good
big
question came in about maybe the heat pumps again, technology, refrigeration. You know, you got to size and select. So the question came in about Pennsylvania for, is this good enough to heat? And the truth is, what is your design date conditions? What is the load required for that design date condition?
What state was that?
Pennsylvania.
Pennsylvania.
Yeah. So if they're doing this up in Vermont,
I was going to say, right?
you're gonna consider redundancy, as we said before, because even earlier with the DX refrigerant and heat pump outdoor unit, no different here. Still running off of R410A currently. So it's only going to give you X amount of BTUs cooling, BTUs heating, and in heating, it will dwindle. You need to know where that doesn't carry the load anymore, because we only have a certain amount of sizes, right? And now we might need to have redundancy or backup. And that could be many options.
Absolutely. It might be multiple outdoor units.
Or the other side is we keep focusing on lowering water temperature and have a lot of heating surface. All of a sudden, we're getting that BTUs with lowering water temperatures. So again, it all kind of plays nice.
Right. So hopefully that answers your question on the outdoor unit. So like I was saying, you know, when we talk about these different water temps and where we can play nice with a heat pump or chiller, right? These are 2 units, thin wall and our high wall. Right? These have ECM blowers in them, right? Nice units, low water temps, as well as chilled water. But this could potentially replace some baseboard that's on the system. If we do, you know, maybe we look at a baseboard house and we have some certain rooms that have too much baseboard, not enough baseboard. We got to go with something like this. We could be a part there. We can play. It's a nice addition. Some good ones.
Yeah.
Good. Touch them.
Let me know when you want. Yeah, let's work in Minnesota. Yeah, we have heat pumps in Minnesota. Again, sizing and selection. You might not get it done, but if you're gathering heat to 10 degrees, 0 degrees outside, that's a huge portion of the heating season. And then for those other Minnesota, sure, it stays cold longer, but then you're going to have to back up fuel, electric, some other means.
I got a nice application picture coming up. Right. We'll talk about some dual fuel and stuff like that. But that's really what it is. It's just understanding your BTUs, you know.
That's right.
This chart and this slide might have all water temps on it. But I'm not worried about the water temps, you know. It's the BTU numbers that we're worried about, right? So we got some other units here that we could play, and it's just, again, being creative. You know, you look at some of these manufacturers now. These guys that I have on a screen, their products are designed and developed around low water temps. So you're going to be able to find and look up, you know, Beacon Morris. Look at a panel rack. What is my entering water temp? How many BTUs am I getting out of it? What is my load? How many BTUs do I need to put into the space? That's really, you'll be able to answer your own questions there. Will it work here? Well, look at your load. Look at what you're going to get out of the machine in your design temps, and that's going to answer that question. It's not so much the water temp itself. You know, going into, I threw this in here too because, you know, I've been dealing with, you know, I threw the Modine, this is our Loadronic, low temperature air handler. I'm sorry, fan coil unit. This guy here is great if you got some commercial applications or garages. You know, I do have one, and I think that's coming up on that next slide, is one of these in a garage, just taking care of the heating. This is a heating only piece, not a cooling. But this little guy here, you know, I've been having conversations over the last year or so now about doing greenhouses, you know, and trying to get rid of the fossil fuels. You know, you look at a greenhouse and they're most likely propane or fuel oil. You know, there's a lot of loss in the systems they currently have. You know, they're losing tons of energy. You know, they're burning a lot of fuel and they're not putting it into the space or what they need. So we can go with low temperature here now with a radiant, you know, we call root bed heating or something like that, where we actually direct our heat to where we need it, the plants, not the space, you know, not the tables, not the slab of, you know, concrete underneath this greenhouse, but you know, we can be creative and do the radiant and then throw one of these Loadronics in there just to kind of take the chill out of the air. We don't really need to keep the place to 60, 70 degrees, right? So, you know, there's some applications, and your minds are probably going right now and thinking of some stuff. We've had some tennis clubs that want to do platform tennis with radiant, you know, like there's so many different low temp where we're looking at heat pumps now, where especially the air to water side. Before I get off of this, I had thrown in the baseboard. Right? On this chart, it shows traditionally down to 160, right? But we have, and this is one of our manufacturers, right? Our compact, you know, that baseboard there, we have charts, you know, so whoever's baseboard you're utilizing today, look at their charts and see they're basically giving us the information now for low temp, you know, whether that be a condensing boiler, but in our world today, it's going to be an air to water heat pump. You know, if I can get the BTUs I need at 120 degrees where my heat pump's going to perform at, you know, the most efficient, then what is the, you know, what's the problem? You know, and there's a couple other things we got to look at. You know, we start to talk about COPs with heat pumps and where are they efficient, you know, and maybe it doesn't make sense. You know, those COPs aren't great enough to really show a savings. And that's what we can hand it off to. I think you're just saying boilers or whatever it is, redundancy, and we have the control strategies within SpacePak now to, you know, we want to hand this off to a boiler at a certain outdoor temp, you know, and get the best efficiency out of both and have some redundancy, you know, where we're not working both of these guys to death, you know. Yeah, we can do that. You know, we can definitely do that. And that's where,
if I may bring up a point.
Go for it.
A lot of questions came in about here, there, how about what we need for Minnesota for cold climates.
Yep.
It comes down to this. Envelope over equipment. If you build the structure or redesign a structure for our value, it reduces what you actually need to heat the space, BTUs. So now playing nice with basically a thermos approach, right? You have these net zeros, almost net zero homes, but the truth is the loads are so small, even in the northern climates. That's the way they're building them, right? So with anything we do, we're so focused on high temp, and it's been fossil fuels forever. And not bashing fossil fuel, but now there's this new technology, and heat pumps have come hugely advanced over what they were 20 years ago.
Oh, absolutely.
And the BTUs that they produce, it varies depending on where you live. And you just better understand what the load is. The envelope requires this on your -5 day. Well, then you better have something that can deliver that. And if it doesn't, but at the efficient side of it, we're grabbing 2/3 free energy from the air. That's the biggest savings. But it only goes so far. So then you use something that maybe is not as efficient, and therefore you use it for the shorter window period of the heating season.
Right.
It's this handshaking back and forth. All right. So it's just, again, you gotta have the mindset, it's not always gonna be only one source. You use what you want, maximize your efficiency, lower your costs. The building is not changing because it was engineered to have a low BTU requirement under design day conditions, load counts.
You know, and Vince, you made a good point. You know, you need a heat source that'll work at very low temps, right? So you think about the U.S. and where we are. And yeah, you guys get some low temps for a couple days here and there, but you know, these heat pumps and their technology now, it's minus 22 degrees heat pump. You know, that's what it's rated to, minus 22.
But what does it
degrees.
produce at that? That's what I really want to know.
And yeah, you know, it's being able to actually get the BTUs out. And we've seen some applications, and I know one of the slides, I keep going back on a picture of it now in our main training, you know, is that one building where they did thermal storage underground. You know, and they had
900 gallons.
I want to say it was close to Canada or Vermont or something like that. It was someplace, you know, pretty damn cold, and their thermal storage, they were pumping the water into a tank underground, and you know, massive, yeah, what was it, 5,000 gallons, whatever it was. They would produce it, and then overnight, and then it would sit in there during the day, and yeah, they weren't getting the full BTUs to make the building 75 degrees, but you know, I don't think that temperature dropped below the, you know, mid to high 60s, you know, in this space, you know, even at negative temperatures. So it was, the units themselves with today's technology, and it's only going to get better in my eyes, there's different refrigerants that are being able to utilize, but you know, it comes down to the BTUs. The machines are able to do it. It's just a matter of, yeah, does that one machine fit every application? No, we have to do a load count. You know, and that's where
right there. How many guys on here, yay or nay, are you doing a heat load count or a heat gain count?
Right.
You need to see the differences because there are really low cooling loads, but then there could be a really high heating load. The heating load is that machine now. Where do you sit? It's grossly oversized because when you switch it from heating mode to cooling mode, then you're causing problems. So now you have to have this happy medium. You know, or maybe you have two separate systems. I don't know. You have to play what's best for the environment because oversizing cooling, you're going to short cycle. You're going to have a lot of humidity, you know, not removing moisture, and then there's mold. So you're causing another series of problems.
That's it.
So play nice and understanding one piece of equipment doing multiple seasons, cooling load, heating load, and you have to pick something that maybe doesn't cover all the heating load. So then you need to play nice with that cooling load closer, maybe a little over on the heating, but now you add an electric boiler. You do some other things, reducing the heat load, maybe do the envelope again. But then by reducing the envelope, your cooling load's probably gonna reduce as well. Warm goes to cool, that's the basis of it all, comfort, right? So 90-degree air, we wanna maintain 70 something in the side, you know, in the summertime. Well,
that's it.
And the same thing with heating.
And that's it.
70 when it's -5.
But it comes down to the design side too. You know, we're talking at some of these areas, and I see some of the guys that are commenting, and they might be in other states and all of that. And it's glad to see that a lot of you guys are doing heat load calculations. But you know, you're doing a heat load calculation, and those numbers are based on the coldest day in your area. You know, your design temp. You know, which might be, you know, single digits, whatever. You know, New York, I know we talk about, I think it's 10 degrees, 10 to 15 degrees is somewhere our design temp at this point. It's gonna probably get warmer as we talk because we haven't really seen much of a winter, but we're talking a couple days, you know, 2 or 3 days, 4 days, 5 days, maybe a week, worst case, right? Overnight, you know, yeah, if we did the math, it's overnight time, you know, so, you know, do we need to size this thing for that day? No, I mean, we want to, but maybe we don't need to. Maybe we can have an electric boiler in conjunction that's going to take care of those colder temps and those colder days and stuff like that. So, you know, design-wise, I mean, we can have a lot of fun with the applications, you know, and stuff like that. And it's just, I like having these conversations and talking about different applications because it just opens things up, you know. Well, can I do this? Can I do that? You know,
How many slides do you have?
2 or 3.
Oh, fantastic. Yeah. I just want to make sure we don't get too heavy into it.
No, I'm not. So move it on.
Quick question about placement of the outdoor unit, regardless if it's a DX, meaning just straight refrigerant, or air to water. I mean, these things are on rooftops. Is there a better performance, north side, south side, shaded, not shaded? You know, you got to be understanding. I'm not really sure performance-wise where they test it for those numbers, but it is an air source regardless. You get them off the ground, make sure you're protecting them from snow loads,
Yep.
Flooding, things of that nature. So maintenance, cleaning the coils.
Yeah.
Everything is specs, brand new. I don't think put foul factors into dirty coils, but the truth is, without maintenance, you have a lot of things on the ground, dirt and dust, landscape, as I say. You got to make sure you get them off the ground for sure, for snow load conditions as well.
Yeah, not to get too much deeper, but you mentioned snow and ice and all of that and being air source. That's one thing with air to water. You don't really have to worry about too much is defrost because you don't see it. It's not like a air to refrigerant or air to air, or I should say. When that thing goes into defrost, you reverse the cycle of the machine, and now you're taking away the heat from the space for a limited amount of time. And the technology's gotten pretty good there, and defrost times are getting a lot shorter. But air to water, when that thing goes into defrost, all that outdoor unit cares about is that buffer tank, if you remember, right? So we're still pumping heat out of that tank into the home. We're not seeing the effects of defrost in the house, but it's still want to make sure that thing is clear. So just wanted to make that point. That was a good segue. So this is just an application. This is something that we work with. It is a dual fuel, right? Hybrid. Right, 2 heat pumps taking care of the heat load here, high velocity as far as the air handlers go up there. And this was, like I said, we used for the garage, we utilized the Lodronic unit there. And then we had our boiler, our gas boiler that took care of the indirect heating, as well as, a redundancy for the heat pumps. If one of them went down, this guy can help it catch up. It could go standalone. We had this set up based off of buffer tank temp. If it dropped to a certain temperature, it would kind of lend a hand. So I saw somebody ask about the control strategy, right? This is automatic. We set a temperature. We could have had this thing come on based on outdoor temperatures where we handshake it from the heat pumps and go to the boiler, but we don't need. We're all low temperature. The heat pumps have been doing a phenomenal job just for heating and cooling. Every once in a while, they hit some really cold temps. Maybe that boiler will kick on and lend a hand and get in that buffer tank up to temperature. So, we can be creative. We had an application not too long ago with a contractor who was almost ready to walk away and saying it's not going to work. But we don't always have to remove the fossil fuel device. If they have a new boiler that they just replaced 5, 6, 7 years ago, 10 years ago, let's call it. Maybe we don't have to get rid of it. Maybe we just size the outdoor unit for a majority of the load and then let the boiler kind of take over on those colder days, So we can kind of get these pieces of equipment into these jobs, not sizing the entire job off the heat pump, but kind of working in conjunction with each other.
People asking about the copper or aluminum fins. Is your equipment copper, aluminum fin, or all aluminum, I guess?
Yeah, I know there was some changes to the indoor, but I believe it's still all copper.
I believe it is.
We didn't go to all aluminum yet.
And how about meeting requirements for NEEP? Obviously, we're grandfathered in with the DX side.
Yeah, water side, and that's what I was saying earlier when we first started is, a lot of the utilities, the NEEP program, NEEP is just, they don't recognize air to water units. We kind of fall underneath the air source heat pump, right? It's an air source heat pump, hands down, but it's a different media. And they don't have, like even AHRI, the directory, they do not have a category for air to water, right? They have ground source. We don't fit into that, because we are a closed loop inside. There is nothing, in the house, in the ground or anything like that. So that's coming. We've been trying to educate people on the NYSERDA level for New York, Con Ed, PSE&G, we work with the utilities. Some of them might even be on here today, which is, we always like that, but it's an education, making them aware. I heard a story, and that's where kind of Vermont went their way was, a homeowner applied for an air source heat pump rebate and got declined because it wasn't a mini split system. It wasn't a ductless system like they claim an air source heat pump should be. Her argument was it's an air source heat pump. It's just not refrigerant. It's not a air to air. It's an air to water. She bought it and they paid her. And they ended up making a separate category. I know Massachusetts has their own. So it's taken a little bit of education, just like we are doing hopefully today to some people that may not have seen any of these products before. But the utility, I think that's all only going to come, as far as NEEP and all that. So that's that application of being creative with a dual fuel type of setup. really nice, functional, easy to maintain. Mostly common parts you're gonna find at a supply house, so nothing, overboard here, try to keep everything simple,
Question came up about Canada possibly using it for domestic as well, which you have a picture of a storage tank.
Yeah, I didn't go that deep into this. I didn't bring it in, but we could hit. Remember, if we're getting 120 degrees out of that heat pump into the buffer tank, we got some heat transfer there.
Preheating, maybe.
That's the term I like to use, is preheating. And we do have some diagrams on how we can do that. If you have some applications you're thinking of, definitely reach out to us. But yeah, you throw an electric water heater in the mix and get a small little braze plate heat exchanger off that buffer tank. We can go with a flow switch there and really now feed that tank. Let's call it 110, 120 degrees of water. We can get up a little higher. I say 120 because that's going to be the sweet spot, but 130 the machines will be able to get. So if I can put 120 degrees into a
Summertime
electric water heater,
applications.
yeah, summertime, perfect. 120 degrees into that tank. Well, even if I put 110 into the tank, how hard is that electric water heater going to work? We're rising that rise we're talking about is maybe
like
20 degrees, 30 degrees, right? Yeah, similar to Geo. So we can get a lot out of it, and then we can hand it off to the electric elements. One of the nice things, our buffer tanks, just kind of plug those electric elements, the buffer tanks we do have, they have electric elements in them, from the small guy, 13 gallon, and then we go all the way up, we get into all the other larger tanks all have dual elements there. So we do have some boost, like you just said, and then we also have maybe the ability to utilize those elements and use a separate tank just for domestic, So there's definitely some things to talk about there, and we love that conversation. This was another funky application. This was, before I kind of throw it out there, you can see the diagram, we got 4 heat pumps. So there was our outdoor side. So this is no different than that basic, layout that I had. You got an outdoor side and then you got an indoor, and doesn't matter how creative you want to be and how crazy you want to get with it, it's still the same system. You got the heat pump side and then you got the system side. So the piping is pretty simple to do. But this was in a home, right? Yeah, it's repeatable. That's a good way to put it. This was 3 air handlers, high velocity. 3 of them were used for heating and cooling of the space, and the other one was a makeup air, where we're doing some tempering of the air coming into the spot. This was not a home. This was not a greenhouse. This was actually an airplane, right? So we have, if you guys are in the New York, New Jersey area, and you've traveled to JFK Airport, JetBlue Terminal, we've got the TWA Hotel down there. So
It doesn't take off anymore, by the way.
yeah, that plane does not
to be
move.
clear.
Would be cool, but a little difficult. So this is an air to water project, and again, it wasn't the air to water that sold this project. It was the high velocity side. It was the small ducts and getting them in the wall cavity of an airplane that really sold this job. Traditionally, they couldn't have done anything, to heat or cool this space. So it went high velocity. We got a lot of those round outlets as well as our linear diffusers in that plane. Some really weird, design, I don't know what you want to call them, unique design requests on this project.
Aesthetics.
Aesthetics, one of them, but heating and cooling a space with the doors open was another, so that's something you don't typically see unless you do it snow melt or something like that. But, this was unique to where remote application. We didn't want to see the outdoor units, a little difficult to see here if you're on a phone, but if you follow the red dot, maybe I'll go with, where's my multiplier? There we go. So right around my arrow there, underneath that prop, you're going to see a little door there. That's actually an access to a little bunker, and there's a little room that houses all of this equipment that you see here. Everything in this dotted box is inside that little bunker. Piping goes underground into the belly of the plane, and that's where you're going to find the air handlers. So again, just being creative applications, you don't have to limit yourself just to homes. There's so many different applications out there.
Someone's asking about the size of the indoor units. Those are our SpacePak Air to water, water coil.
Yeah, and the air handlers themselves don't change. They're the same, 14 and a half dimension. I'll show you where to get that information. So that's a great question coming up on the next slide. But yes, these are just a couple applications there that we've worked on. This was a Wales Darby design. Our engineering team put this together, and it's functional, it works. So if you've ever been there and you've been through the plane and you were comfortable, you can thank SpacePak and Wales Darby.
I don't think it shows, but this question came about controlling, like with a boiler, our boy Jeff Kelly.
Yeah.
And does multi-unit installs have linked systems and similar?
Yeah, so
Something
we had systems, we had controls, in the past, with joining multiple heat pumps. We do have our SpacePak, we call it SSIC. It's really meant for one heat pump. But we do have some new stuff coming out, new controls with the newer inverters that are out there. So some stuff coming. We could do some, in some of the applications, like even that other one, I try to keep it basic, to Jeff's point. Yeah, there are controls out there, maybe doing a multi-heat pump
How do we control
controlling, and handing them off, staging them, if you would say. We have some ways of doing that just with temperatures within the units, basically offsetting temperatures in the heat pumps. We could do a full, I like simplicity, right? So I know the guy that's got to go back there, I want to make his job easy. So sometimes designing a control strategy with staging and all of that may be, you need a special skill set. And that's where I kind of go to this air to water side, because how simple it is. We can complicate it very easily, but it is pretty simple when we look at it, where, you're talking geothermal, I could talk to 10 contractors about geothermal and they've all heard about it, but very rarely do you find somebody that's specialized in it and knows how to fix it, So, I try to watch what controls we do put with the system. We do have some partners out there that we've worked with. It may not be a Wales Darby product, but we have some good stuff that's out there today that we've looked at, and we would recommend, if it's the application matches that. Good question, Jeff. Appreciate you. So we're talking
Where do you
solar,
find the
water,
handouts?
preheating.
Someone's just I'm just trying to show them orange arrow.
Yeah, you're gonna find your dashboard, little orange arrow that's gonna pull out a little box, and then you're gonna have a handout section there. It'll say 5 of 5, and you'll be able to find that material there.
A lot of good stuff in there for you guys today.
Man, we've got a lot of questions. If we don't get to your questions today, we will be able to review this, and one of our, if not us directly or our outside salespeople, will reach out to you and get you the answers you need. I see tons of questions still coming in.
How do you switch from heating to cooling?
Yeah, switching.
It's
talk
all
about switching heating to cooling. So yeah, so
could be
basically
your,
it's a
could be your
demand.
command, could be your thermostat.
So all of our heat pumps, what are nice is control strategy. Again, very simple. We have 2 basically dry contacts we're sending out there. One of them's on off to tell the machine to turn on and turn off. The other one is to turn the reversing valve in the direction we need. So if you have a, was that Stephen? Stephen, if you had a cooling application, it's gonna. What's that? Joe. Oh. So you have a cooling application. Maybe we close the contact for the reversing valve. Maybe we don't, right? So it's all dependent on what that buffer tank needs, right? So it's not so much about what you're doing. Obviously, if you have a cooling call, that buffer tank's going to recognize it. The control that we have is going to recognize the cooling call. That tank's 120 degrees already. It's going to swap that over, repump that water back to the outdoor unit, and chill it down to 44 degrees in less than 5 minutes in some cases. But if you have, efficiency-wise, is that we just took a whole tank of 120 degree water, right? And we just dropped it to 44 degrees, and then we're gonna have to reheat it again on a heating coil. So if we have those opportunities to have these mixed heating and cooling opportunities, I guess you can call having dual buffer tanks is not a bad thing to have. Have a cooling tank and have a heating tank. You can draw off of them independently, and the outdoor unit's gonna maintain the temperature in them, depending on which one needs it. So if we have heating and cooling simultaneously and we're pulling from 2 different tanks, maybe a fan coil unit's doing cooling and we're doing some pre-warming, or we're doing some floor conditioning with a heated tank, I can literally draw off of both of those tanks, and whichever one calls first, that outdoor unit's going to satisfy. It's going to take care of that guy and get it back to where it needs to be, and then it'll switch over to the next. So there's a lot of, again, I don't want to get too off into the weeds, but we can be creative. All the questions you're asking, I think we've seen already, and we pretty much have an answer for. Joseph's got his answer.
I'm just going to tap into something about the choice of piping and glycol, and then sizing and selection, right? So PEX is a very popular choice of material. SDR9. So ID of half-inch PEX is not that ID of half-inch copper or steel. So know what it does for your pump selection, and then you add glycol. Make sure you're only using glycol required to maintain a freeze protection. And be aware what it says when it says -30 or whatever god-awful temperature you think you need to protect to. Don't over glycol. You start to create more of a headache, and then your pump becomes a problem, not transferring heat or cooling, and then we're not looking at the glycol. It needs to be maintained as well. It only has a shelf life of X, so you test it and you recharge it if you have to. But PEX tubing, I like the material versus maybe, hey, this is heating and we think steel rusts. There's issues perhaps with some of our water pathways, if you want to say that, through some heat exchangers. So just for fouling factors, try and use a non-metallic pipe, copper, brass perhaps for low, for close piping. But not to say steel cannot be used, but just understand what happens with longevity using the system over time.
Yeah, absolutely, maintenance, high efficiency, right?
Yeah.
So we got some good, Stephen, long refrigerant lines for an airplane. Actually, there's not one refrigerant line on this entire job, which is nice with air to water, right? It's just pumping and piping to what Anthony was just talking about, That was PEX tubing running on the ground into the belly of the plane. Actually, it wasn't, it was copper they ran, I lied. But they ran copper and insulated and all of that stuff. So it's all water lines. We're not limited to refrigerant lines and all of that stuff, which is really nice what we talk about. Believe it or not, the contractor that won the bid for this job saw the layout, didn't know anything about air to water, and actually tried swapping this whole job to DX refrigerant, and it was not going to happen because they could not do that, what you were just saying. They could not do the long lengths with the refrigerant lines. They would have had to run 4 condensers, 4, runs of pipe, it would have been a nightmare. So the only thing that made sense here was the air to water. So it was a good comment. I saw that one. So a lot of the information we gave you was just general information, some best practices stuff, some of the things that we do see, application design, stuff like that, maybe things just enough to get you guys thinking.
Has anyone ever been to SpacePak in Massachusetts? Thinking about going to the factory, doing a tour, doing a training, seeing it live fire. These are really good opportunities in this technology jump. And if you need to, please let us know. If you're local, you're trying to gather people to go up there.
Yep. I was just going to say, on a
it's a great company to get involved with. Mestech is the mothership. There's a lot of products under that flag, and SpacePak being one of them.
Yeah, training wise, like I said, we do offer a certification training. Reach out to your distributor, inquire, ask them for it, tell them you want it. You'll get some extended warranties. You'll get opportunities to be on our leads list, where you will get leads from SpacePak. The conversations about air to water heat pumps, I forget who said it before, right? I mentioned it earlier about the heat pump conversation in general, not just the high velocity for us, but heat pumps has been nuts. The other day, I came down to our remote office over here, and I spent almost 4 hours in the car. I couldn't get out of the car because the phone. I took five conversations, all focused around air to water. And it's in the past couple years, those were refrigerant, mini split, phone calls. Those are ductless mini split calls, and now this transition, getting people aware of pumping and piping. Like I said to that one gentleman, he's not on today, I thought he might make it. He did a certification class with us and a transition of his business and try to evolve and really keep up with everything that's going on and the changes, and not want to, kind of get, I don't know, what's the word, getting eaten up. There's a lot of businesses that are going to have to change with a lot of this electrification. And
Change your diet.
they're one of them that is really evolving around it. And it's been good, but he was telling me originally going out and finding 6 new guys, hiring 6 new guys, which I said right off the bat, good luck. Now you got to find 6 guys of somewhat good quality, right? Get the licenses, get the tools, just so we can say we're selling a mini split. It don't make sense to me. This makes sense to me. If you're a plumber out there, or you're a hydronic guy out there that hasn't really kind of grabbed a hold of the heat pump world, this is a good opportunity for you. This is your world. You don't have to touch the refrigerant. You put a unit in, you're pumping and piping, and then you're off, you know, so there's some good conversation there. So all the information we gave you, I threw on here, the SpacePak website.
Good. Where are they located in Massachusetts?
Westfield, Mass.
Westfield, yes.
Westfield, Mass. So great little town. So we are trying to plan some stuff up there with some good guys. So if you're interested, reach out to us. I'll
There's
just say
a question
that.
here about is air to water as efficient as air to air? And
Yeah, if not more.
you gotta consider a couple factors.
Yeah.
Refrigerant line sets, you're limited.
Yeah.
Right. So you might need more equipment to cover the area where water. I mean, a BTU is a BTU, and if both equipment are equal and making BTUs, man, the other side of it is delivery and sustaining your BTU potential. Yeah. Refrigerant loses its potential the longer it goes. So shorter is better, right? So unless you're switching to some other terminal unit, but
You think about the footprint too.
air to water is hugely flexible with zoning, distance, and I don't know, flexibility. Just it doesn't change the medium.
Yeah, we go air to air, you know, even if it's ductless. Okay, ductless is one thing. We're seeing a lot of this ducted systems with the mini split world. You know, you're running duct work, and what we can do with a 3/4 inch pipe or a 1 inch pipe, and how many BTUs. You know, when you talk about efficiency, it's all going to come down to COPs. And I think the equipment, whether it's air to air or air to water, you're going to see, you know, the COPs are there. You know, the efficiency is definitely there. It really comes down to flexibility in my eyes, redundancy. You know, yeah, we can do some stuff with dual fuel, with air to air, but when we're talking hydronics, you know, and boilers and everything else, we see a lot of boilers here in the Northeast, hydronics in our world. Air to air, air to water just makes sense, you know, but that's our opinions.
People have been doing water for many, many decades in their business, family, you know, passed down generations. Their comfort level with water and piping and pumping is going to boggle their mind if they think the only thing they're being forced to do is refrigerant.
Yeah.
If Rick mentioned it earlier, everything we talk about with our air to water, the refrigerant is pretty much sealed.
Yeah.
There's really no need to touch it.
Right. So, you know, just thinking about air to water in general too, you know, I was just thinking, you know, commercially, you know, we kind of spent a lot of our time talking about residential focus and some other applications, but, you know, we talk about radiant, you know, and chilled water and being able to do radiant cooling and knock down a cooling load. And now maybe I could go with a smaller, you know, on the air side, I can go with a smaller unit because you diminish that cooling load so much, you know, just by doing the radiant cooling, but now we need humidity control. I'm not going too far off from there.
Martin, absolutely. ProPress on anything you want to do today. Just no different. I'm just talking about the material itself.
Yep.
So ProPress, solder.
Yeah, it depends on what is your skill. You know, that's really what it comes down to. So a lot of, as we kind of wind down here and kind of weed through some of these other questions as we're closing up here, but any of the information we talked about today have not been on SpacePak's website. Take a look. This is the face of it here. There is a, you know, technical library where you can get, if you click right here on this spot, technical library, it's going to bring you to a page that looks like this. You'll be able to kind of click on here and kind of go through by the type of information you're looking for, whether it's a brochure, a submittal, you know, whatever it may be, an install manual. You can break it down by the actual product category as well as down to the model. You will see a lot of information here, a lot of verbiage. All your downloads are here. You're going to click on these links to the left, and that will get you. You can see product data sheets, install manuals, brochures, so a lot of different information there. So anything we talked about today, whether it's older SpacePak, new SpacePak, hydronics, whatever it is, you'll be able to find it here. So we got, as you guys know, you guys been with us for a while, most of you. You know, we're on a weekly basis here. We've been doing this for a couple of years now. This is a little look at the new website for Wales Darby. If you have not been there, that's where you'll be able to sign up for many of these webinars. So walesdarby.com. You're going to click up here to the training and events tab, go down to the calendar, and you'll see this guy. Some of the upcoming classes we do have, we'll be talking again, you know, heat pump conversation, going into taking a look at what Takeo just came out with their heat pump. We're going to talk about some radiant heating on the 15th of March. Jim DePalma will be doing that. And then we got Rob and Jim on the Fujitsu multi-position air handler on the 22nd. And then you'll have myself and Anthony back again on the 29th, talking about some Fujitsu resources. So again, I saw a question in there before. Somebody asked about recordings. As always, we do record these webinars. This is being recorded. We will take this over the next couple of days. It will be brought to this website you see in front of you, walesdarby.com. Again, you go to training and events, and you will find all of the recorded videos, past and present, pretty much everything that we have done. So take a look, sign up for some of these other classes. Love having you guys, love the conversation. Tons of conversation this morning, so that's been great. So with that, you got anything else you want to bring up, Ed?
I'm working over here.
You're typing away. So we appreciate the interaction, because that's definitely a big part of doing a webinar. You're staring at a blank screen for an hour and a half.
It's really good this morning. A lot of great questions. Good to see everybody interacting. It really just makes it, for us, it just makes it better for you. When we have questions we can share, we're all kind of in the same spot. Technology is going to kick our ass, and we need to grab it at some point. The baseline I always talk about is envelope over equipment, lowering water temperature, do your heat loss calcs, heat gains. You'll never go wrong. And this way you will know, with a lot of selection of different good equipment out there, man, technology will always be something to be aware of.
Absolutely.
And we're going to get forced to rise to rebates or efficiency levels, COPs, all the above. And if you're not prepared, it can be very overwhelming. So we're here to help.
That's it.
Right? We're here to help. More information, the better.
How are you looking question-wise?
The audio stopped for some reason. I don't hear it now, unless my thing died. It didn't tell me.
Yeah, it could be. We're still up there. Let's see the
Okay.
audio. All right. So question-wise, I don't see a bunch of thank yous.
There we go. Love you, boys.
Thanks for joining us, Chris.
Thank you. No, excellent. All
Awesome,
goodbyes
guys.
and thank yous. And
Glad it helped. If you missed anything, you got our contact info on the screen there, little QR code. You can scan that if you haven't already. Phone numbers, emails. You also got the handouts. Don't forget them on the way out. You got 30 seconds, if not.
Instagram, if you guys are on social media, take a look. We have a lot of stuff we'd like to share and get involved with. Show us what you guys are involved.
Absolutely.
Always good to see.
Absolutely. All right. So with that,
we're frozen a little bit, at least on the. There we go. We're back.
Yep. Yeah, it could be the Wi-Fi. All right, guys. We'll appreciate the questions, the comments, the interaction. Thanks for joining us, and we'll see you again next week. Have a good day.
Peace.